This meeting is being recorded.
Assalamualaikum and a very good day. So this is Madam Johanna speaking here. This week's lecture will be asynchronous on the chapter of vector, which will be included in your final exam. And this chapter will be divided into 3 parts. So the first, so you are required to watch all of the 3 videos first before you are allowed to click on the attendance link provided on your ITEL. Okay, so let's start. We're going to start this part of the video, this part of the lecture with the first part of the lecture, which is introduction on vectors. So by now, you should be able to understand that vector is actually a movement of a point or an object. Okay, so vector is usually applied into weather or into spatial information. And it is usually represented with these with these signs right here lah. So kalau nampak these signs here, that means it is being represented by a vector. And vector ni selalu dia akan ada direction, whether it is going up or whether it's going down or whether it's going left, right, or mana-mana lah. Okay, and this movement, it will come with an amount of a magnitude. So that means, let's say we're looking at the application of vector in weather. Okay, so when we're looking at a movement of something, we can say that the magnitude is the speed of the wind or the humidity. So there memang ada weightage there. Okay, but at your level right now, we are looking at it as something that only moves in points. Okay, so this is the vector AB. Okay, so vector AB will always be heading that way. So I'm going to draw a new vector. So this is still AB, especially if it is the same length. Okay, but if it is double the length, so that means this is AB. Contohnya lah kan, this is AB and it's heading into the same direction. I'm going to write another one here, which is the exact same length. So this would be 2AB. So all in all, it has to be moving in the exact same direction. Okay, so two vectors are only equal if it has the same magnitude and the same direction. Dalam kata lain, vector tu kalau dia sama, then panjang dia pun sama, arah dia pun sama. Okay, but if it is heading into the opposite direction, then it would be a negative vector. There must be into the total opposite. Let's say this blue line here, kan dia menghadap that way. So if I'm going to draw another vector this way, then it would be going towards the negative. So when this happens, you add a negative in front of your vector representation. It could also be twice as long, so maybe it would be negative 2A. Okay, so but yang penting, if it is heading towards the opposite direction, then that means it is a negative. Okay, so at your level, actually kita sudah sampai 3-dimensional space. Okay, but this is just to quickly recap what you've learned in your secondary school. Okay, paksi Y selalu represent the J vector. Paksi X is your I vector. Okay, so in 3D, you're going to imagine this is your paksi Y, this is your paksi X, okay? But this is instead of paksi, it is actually a piece of paper. Let's imagine this is a paper, okay? And you're holding this paper. Okay, so you're holding this paper. Now you're gonna put this paper on the floor. So I'm gonna draw another image here. Not the nicest piece of paper that's gonna be put on the floor. Let me redraw that. Okay, so gonna imagine you take this piece of paper, gonna put it on the floor. So this is your floor right now. It's not so flat. Okay, so ini paksi Y, ini paksi X, and you're standing at this corner here at the origin. Okay, so you're looking down at your paper. Going in front of you is paksi Y. going to your right is paksi x. Of course, if it goes to your left, then it would be the negative of paksi x. And if it goes behind you, then it would be the negative of paksi y. Now, what are you? U is what the third axis will be, which is paksi z. So if it goes underground, that would be the negative of z axis. So this is how you vision how your 3D vector should be. Okay, so when it was 2D, you would represent the x-axis with the I vector, the y-axis with the j vector, and this is how it is written in matrix. So kalau paksi z, it will usually be represented with k, and instead of writing 1, 0, 0 for the I, you write 1, 0, 0, 0, so you add another paksi there. So J pun jadi 010. So K pun dia akan jadi 001. Contohnya lah, if your vector is on point 1, 1, 1. Okay. So your vector O to P, let's say you have a Z vector here. So it will look like 1, 1, 1. And then this would look like Z1, K. Okay, ini kalau 3D. So next slide. Okay, so let's look at this example. So we are immediately entering the 3D world. Okay, O, A, B, C, D, E, F, G is a cube of a side 3 centimeters. Okay, so anywhere O to A, 3 cm, O to E, 3 cm, O to G, 3 cm. So all these will represent 3 centimeters. O is the origin. Okay, ingat lah, kita selalu mau start di origin. Okay, we must always start at the origin. And unit vectors I, J, and K are parallel to OA, OG, and OE respectively. Okay, so those blue lines telling you your axis. Okay, so express each of the vector OB, OC, and GF in terms of I, J, and K. Okay, so let's start with that. So OB, di mana OB? Oh, this is B. Okay, let's mark OB. So that is O. The first purple dot is O. The second purple dot is B. So let's draw that line. So we want to head from O to B. Okay, so memang tiada jalan lah di tengah ni kan. So you have to follow the lines. So you're going to have to go from O to A first, which is 3 centimeters, 3 points on the x-axis. So we're going to write down 3I, and then we're going to go up, which is on paksi Y, okay, on the y-axis, another 3 points. So that would be your vector. Let's say lah kan, you want to go from O to B lah, okay? So that is your destination, but you decided that you don't want to go from O to A to B. Instead, you want to go somewhere else, like from O to E. Okay, so you're going up 3 points. So that would be plus 3K. And then you want to go turn right from E to F. So that would make it 3 points to the right. That means a positive 3I. Okay, and then you go on the y-axis. On the y-axis, you're going forward 3 points, so that's plus 3j, and then you go down, which is, oh no, wait, we're going left first. Okay, we're going left, so that's negative of 3i. Baru turun lagi. Okay, so that's the negative of the k-axis, that would be negative 3k. Then we turn back to the right again, which is plus 3i. It should and it must still equal to the original vector that we calculated in the previous slide. Okay, kalau salah, then that means you're going the wrong side lah. Okay, so next question, we want to determine the vector of OC. So let's draw OC. There we go. All right, so we're going to go from O to A, which is 3I positive. And then from A, we go to B, which is also a positive on the y-axis, so plus 3j. And then we're going to go up 3 points. Okay, that means it's plus 3. Okay, so by now, straightforward lah kan? Nampak sudah? Right, but what if now we don't want to start from the origin? What if we want to go from one point to another that is not requiring us to start from the origin. Okay, it's actually still the same thing. Okay, so to get from G to F, we're going to move 3 points to the right. So that gives you 3i. And then we're going to move 3 points backwards on the y-axis. So that gives you a negative 3j. And then we're going to go up 3 points on the k-axis. So that gives you plus 3k. Okay, so sama juga sebenarnya. Okay, let's look at another example. Wait, no. Oh, this is an exercise. So you're supposed to try this out. Okay, but it's pretty straightforward. Okay, sketch it out so you can visualize before you obtain these answers here. Okay, mesti try ya. Anyway, let's get into position vector, OP. Can be written in various ways, whether it is in matrix form or in equation form, where you can individualize your matrix for paxi I, paxi J, and also if there's a K, then you would be able to do that lah. Let's say it's just one lah. Okay, but position vector, what you should realize about position vector here, the word position vector, is that it must always start from the origin. Okay, dia mesti mula dari origin. So just like any other mathematical problems, we will have to deal with addition and subtraction. Okay, so they are quite straightforward. Kalau yang berada di paksi paksi X, or the J or the I, then it should be together, and those on the paksi Y should be together lah. Okay, kalau dia tambah, kalau dia tolak. This is basic algebra lah. Okay, and if there is alpha, which is any number, and you are going to multiply it into your vector, therefore you can put it out and then multiply it one by one into the equation. Okay. So let's say you are looking for vector AC, macam ni. Okay, so from A to C, but you only know A to B. You only know the vector of A to B and B to C. So therefore AC would be the addition of vector AB plus BC. Macam tadi lah kita buat in the cube example. So given A that has a coordinate of 4, negative 1, and B has a coordinate of 2, 3, find AB. Okay, so we're looking for the coordinate of AB. So but what do we know? What we know is that the position vector of OA, which is O to A, is 4i minus j. Okay, this is here. And the position of vector of OB is 2i minus plus 3j. Okay, but so with this information here, we should be able to find A, B, which is A to O dulu. So the negative of OA, okay, plus OB. Okay, so kita semua ni masuk dalam sini, and you should be able to get your vector of AB. Now, what if we have to multiply it by a scalar? When we multiply a vector by a scalar lambda, then lambda v is a vector which direction depends upon the sign of lambda. If lambda is the same positive, then the direction is the same, but sometimes it could also be negative. For example, let us look at u here. So this is vector u. So when it's 2u, then it should be double the magnitude. Okay, then if it's 6u, then it would be 6 times the magnitude. Okay, and then when it is negative 2, then it should be heading the opposite direction instead. Same goes for this example here, this v. Okay. Alright, position vector O is the origin. Okay, so ini sudah ulang juga actually. The previous few slides sudah cakap pasal position vector. It must always start from the origin. Okay, so it cannot be shifted around sebab origin ni memang di kosong-kosong sahaja. Okay, so position vector of any point PAB is I plus J. So you can imagine if there's a paksi Z, then it should be C plus CK. Okay. Right. So position vector in 3D, inilah position vector in 3D, it should look like this. Okay, so for A in paxi X, the positive direction of paxi X, B, the positive direction of paxi Y, okay, and C is the positive direction of paxi K. Okay, let's look at this example. A triangle ABC has its vertices at points A, B, and C. Okay, find in the form of AI plus BJ plus CK the vectors AB, BC, and CA, and hence find the perimeter of the triangle. Okay, so the best thing to do when it comes to vectors like this is to sketch it out. You must sketch it out so you can really see what goes where. You're probably thinking, Madam, I really don't know where 2, negative 1, 4 is on the graph. It's okay. You cincai only. Maybe A is on the left, maybe A is on the right, maybe A is a little higher. It's okay as long as you sketch. So we're going to do just that right now. We're going to sketch. Okay. There's some missing things here. I don't know why. Okay, but I hope you can add that on your own. Okay, so I'm going to write down contohnya lah kan. A, B, and C are here. Alright, but I definitely know their position vector, right? So I can definitely anggarkan, okay, that O, the origin, starts here. Okay, so since the origin starts here, that means my OA is 2i minus j plus 4k. My OB is 3i minus 2j plus 5k. And my OC is minus i, plus 6j plus 2k. Okay, so this is our position vector. From the coordinates, from the points, you should be able to write down your position vector. So bila sudah ada position vector, then we can definitely look for our vectors AB, BC, and CA. So how do we do that? So it's a triangle representing AB, BC, and CA. AB, BC, and CA. So to get from A to B, we know AO and we know OB, right? So AB is AO plus OB. So kita masukkan vector, right? And we should be able to obtain AB. So now let's look for, again, BC. Okay, we're looking for BC, but to get to BC, then B has to go back to O first, baru O balik ke C, because that is all we know. Okay, we only have that information, so we must use that information. So putting our vectors into that, we should be able to obtain the vector of BC. And then last kali, CA. Okay, so again, from C to get to A, C has to go back to O dulu, baru O naik ke A. Okay, so CO plus OA. Alright, so put our vectors in, and then we obtain our vector of AB, BC, and CA. But wait, the question said, hence find the perimeter of the triangle. So that means we need to look for your magnitude. Means what is the weightage of each of these vectors. Okay, so how to look for magnitude? How to look for magnitude is that when you modulus your vector, and you take each coefficient of I, coefficient of J, coefficient of K, take it all and you square. Okay, so contohnya di sini 1I, so kita letakkan 1 squared, negative 1J, so you take negative 1 squared, and last kali plus K, so kita plus 1 squared K. So the same goes for your BC and your CA. Sama sahaja, kita ambil the points on your paxi I, paxi J, and paxi K, square them, plus them, and then square root. So therefore, the perimeter of your triangle is the addition of all of these magnitudes. Dapatlah 19 units. Okay, so next example. P has the position vector P, and Q has the position vector Q. Hence, find the following vectors in terms of P and Q. Okay, so what do we know here? Okay, we're looking for PQ. Alright, so we know P and Q. Okay, this is P and Q. We also know O. So OP we know, OQ kita tahu. But what is P Q. So that means P kena balik pergi O dulu, baru boleh pergi Q. So we write that down. Okay, same goes for Q, QP. Okay, Q kena balik pergi O dulu, baru boleh pergi P. So we write this down to get our answers. Alright, so the modulus of a vector. Modulus is called the magnitude. So the modulus of a vector is denoted by the symbol right here where we modulus it, and the length is denoted by the symbol modulus. Lepas tu tulislah vector A di dalam tu. Okay. Alright, so magnitude macam tadi juga, we just take the the coefficient of I, the coefficient of B, square them, lepas tu kita square root. So this is a very common question lah. So what does it mean when we have a zero vector? It will be denoted by O, and it has a magnitude of 0, and it has no specific direction. Ini yang penting, dia di situ saja. Okay, so non-zero vectors, kalau A and B are in the same direction, that means it is parallel. Tapi B could be longer than A or shorter than A. Or in the opposite direction pun boleh. Janji dia direction yang sama. So these are called parallel vector. So unit vector is also very important, often forgotten by a lot of people. Okay, unit vector just basically mean that when the magnitude is only one unit, therefore it is called the unit vector. Okay, so ingat dia one unit sahaja. So how does this happen? So you take the vector, you just divide it by the magnitude. Okay, so find a unit vector parallel to the vector A, 5i plus 2j plus 3k. So first we're looking for the unit vector, right? So first and foremost, we need to know what is the magnitude. Okay, so therefore we start by calculating the magnitude. Okay, so dah dapat magnitude, just take the whole vector, divide it by the magnitude, and we get our unit vector. There you go. So this is an exercise that you should try out. The answers are given. So with that, I'm ending the first part of the lecture. So I'll see you in the, we'll meet again in the next part of the lecture, second part of the lecture. Thank you.